Hello everyone. Today I will be going around covering how to integrate Stockfish for our chess robot simulation so that we could have the chess robot play against itself by using the Stockfish AI. So in the last video, I had talked about how we take an input, which is a chess notation, and then move the robot to that particular square and then move it with respect to the chess notation given. What I wanted to do from here is that just get a input like start, and then the robot must be able to play with itself. That is, it should be able to generate these chess notations and get the robot to move for white as well as black, as you can see over here. So in order to do this, there are a few things which we need to go through, um, which is that um, at the first we need to set up this whole pipeline wherein we have services uh, which are running, which help this whole execution possible. So if you see here, this is a topic where if we publish start, it goes through the task planning, and then the task planning gives the chessboard state to the chess AI service. The chess AI service receives this particular chessboard state, and using that particular state, it gives the best move from there. And what this task planning then does is that it takes this chess move, it converts it into the robot coordinates, and then it sends this desired pose to robot path planning service. This robot path planning service uses Moveit to do the path planning, get the robot moving. And once all this path planning and the movement of the robot is completed, it sends back a message saying that it's completed. So then the task planning, once it receives that this uh, movement for the robot is completed, it again updates the chessboard state and then sends to the chess AI service regarding the current state, and then this loop goes on. So this enables a smooth flow of information such that once initiated, the robot keeps playing with itself. So let's break it down into two different segments. One is the chess AI service. So this AI service, what it does is that it receives the chessboard state. And how it receives the chessboard state is pretty important if you want to implement Stockfish, is that it takes in a notation called FEN notation, which is a string-based notation of what the chessboard looks like. As in, if you see here, this represents this particular um, chessboard state, wherein this the rook, bishop, queen, and so on. With respect to its chess notation, this is how it is represented. And this represents whose move it is to play, and then this represents whether the castling has been done, and this represents how many moves have been made. The next one is that once it receives the state, it has to give back what's the next best move. So what the chess AI service does is that it gives back the start and end square, which is combined together, this UCI chess notation, and then it gives whether this move corresponds to a castling, and also it tells whether this move is corresponding to a capture. This information is important because based on this, we would change the poses which we give to the robot, because if it is a capture, we need to take out the piece first and then move it. And similarly, castling needs two different is different from a normal chess move. So this is what this is a string of this information in the sequence, which is passed down to the task planning. Once the task planning receives this particular string of information, it utilizes this the start and end square, and it formulates it into robot poses, which we had discussed in the previous video. And using that, it passes this information down to the robot path planning service. The robot path planning service then utilizes this pose. It iterates through these poses, which it needs to go to. And then once it has completed moving to these particular poses, it sends back that the task has been completed. So this finishes one full cycle wherein it says that this has moved based on the input given from the chess AI service. And then with this information, we update the chessboard state with this particular move. And then we send that chessboard state back to the chess AI service. So this is the loop which goes on so that the robot is playing chess with itself. Moving on. So the integral part in order to create all of this is services. And services serve as the backbone for this entire setup, what we have done. What's good with services is that it always gives you, it's like a request and feedback system. So you ask something to a particular node and then it gives back a response. And that's exactly what we want here, because in both the cases, we have a particular state, and based on that particular state, we need an output with respect to that. So in order to create a service, first we need to create a package for a chess robot service. This is one of the methods to creating service, and this is much more easier than creating a service in a particular node, because by doing so, we can access this particular services in any other packages in our workspace. So first we create a package named chess robot works service, and then inside we create a folder called SRB, and here we create chess AI's chess AI.srb and the motion planning.srb. These are the two services we use in order to establish the whole system. And if we take, for example, chess AI SRB, we give in the request, which is chessboard state, and the response, which is the command. Once this is set up, we then modify the CMake list because we are generating a message every time and it's a service. So there are some things which we need to change from the default CMake list. First, we need to add in message generation and add in message runtime and find packages. Number two, we need to uncomment this particular block and add in the services which we are using, that is the chess AI service and motion planning service. Similarly, in Catkin packages, we have to add in Catkin depends, message generation, all these packages which it depends. And also, yeah, these are the things which we need to update in our CMake list. And similarly, in our package XML, we need to update um, we need to have message runtime, which would not be defined initially in both build depend and execute depend. And then we need to have raw spy, standard message, all these set of things in the package.xml. Only then the whole services would be compiled properly and then can be accessed in other packages. Once we have done that, we can do a catkin make. And now these services would be accessible from other packages in that same workspace. For example, if we want to make a server in the services, for example, the server here is the chess AI service. That's the server. And the task planning is the client. So in this case, for the server, how we have to modify it is that we need to import these services, chess robot services, and the particular service which we are using. And once we do that, we initialize this particular node, chess AI node, and we start the service. How we start the services is that we give a name to the service. Here we are calling it as chess AI service. And then we give the type of service we're using. That is the chess AI service, which we had defined earlier. And then we give a service handle. This service handle is similar to the callbacks function, which we use in normal messages and topics, which is another form of communication in ROS. So once this is set up, then we would be able to access the particular individual request and response in that particular service by using its name, or even using chess AI and capital R. With a capital R, if you type a response, this would also is equivalent to referring to the response which we had created. So this is the server part, and for a service we need a server and client, and for a client, similarly we import both the services, and then in here, this is how we initialize this service, is that we use we're using a helper function here, and here what it does is that it's first waits for the service. We need to give wait service, wait for the service and the service name. Here the service name is just AI service, and then we define ROSPy service proxy. The service name is chess AI service, and the service message, which is chess AI. Um, Once we do this, the service is set up, and this is just to show that, just to give us the indicator that the service is connected. Um, Once this connection is established, then we can access the particular command from the service. So how we access is that we take the chessboard state, which is defined over here. We pass it down to this chess AI service, and this outputs uh, the so this outputs the command, which can be accessed by dot command, and then we get this move command using the using this service. So this is how we establish the services and the whole pipeline for the AI system to communicate with the robots path planning systems. Apart from establishing the services, what I also did was that I added a collision representation to represent the bottom of the top of the table, so that the robot doesn't plan thinking that there is no table over there. So this gives a constraint in the planning space. And also I converted from the normal path planning to Cartesian path planning, so that it gives more predictable motion planning. So these were two things I added so that the robot doesn't uh, do give plan, like it doesn't plan for unfeasible solutions wherein it can collide with the table, or also it just takes more uh, longer path instead of the shortest path. So this is done using these things. Like here, this is how I implemented the collision for the table, and this is how we utilize Cartesian path planning here. So with all this basic things set up, now we will be able to simulate the whole process, and this is how it looks like. So we publish start, and once this is published here, we see this state, the robot state, and the Stockfish AI gives you the command. And similarly, there's another state, and it gives you a command here. And so you can see here that every time a chessboard state is passed down, and then this passes what is the correct move to move uh, for the task planning, and then that commands the robot to move to a particular state. If you see here, this has given this command, and you see here that moves the knight here. Um, So this is the entirety of the simulation and how I have implemented this. Uh, post Post this, what I plan to do is to enable the pick and place. So for doing this, we need to configure each chest coins, how tall they are, and what's the thickness. And based on that, we need to open the gripper and close the gripper, and also we need to take into account for cases such as castling, capture, so that we send in the poses accordingly. Um, so that has to be included in the pipeline. And once that is done, I plan to work on the camera aspect where um, it also detects what the current chess state is so that we could potentially play against the robot using this whole setup. So something what I wanted to thank is I wanted to thank the Ross chess agent package from Max Lab, which is my lab too, where I utilize the chess AI node to implement this whole setup. And yeah, this is the end of my presentation. Thank you everyone for listening to me.